Hey there, awesome physics students. Let's talk about the intimate connection between work and kinetic energy. We're going to give precise meaning to the phrase work changes kinetic energy. Let's start with an example. Imagine that you have a cart on the ground and it's rolling this way, so its displacement vector points that way. And in this case, we're going to say we put a force on it in the same direction as the displacement. In this case, the work done on the object is going to be positive. What does it do in this case, though? It speeds up. So what happens to its kinetic energy? Its kinetic energy increases. So its change in kinetic energy is positive. Okay, let's think about doing something slightly different with this cart. Let's say we put a force on it up, but it still has a displacement vector that points in the same direction. How much work is done in this case? Well, because these two are perpendicular to each other, the work done is zero, right? No part of the force and the displacement are parallel to each other, and so you get zero work. What happens to the kinetic energy? What does this force do? I think intuitively you can see that this force doesn't really change the speed of the cart, right? It doesn't speed it up or slow it down. So the change in kinetic energy in this case is zero. It does not speed up or slow down. Finally, let's imagine that same cart and the displacement in the same direction, but now let's put the force in the opposite direction as the displacement. In this case, the force and the displacement are anti-parallel, and so the work done is going to be negative. Well, what does negative work do to kinetic energy? Well, intuitively, is this thing going to speed up or slow down? I think you can see that the force in this case is going to slow it down. So the change in kinetic energy is going to be negative, just the same as the work. And in fact, the work energy theorem is that the net work done is equal to the change in kinetic energy. They're the same kind of thing. Now, what do I mean by net work? That means that if you think about all the forces acting on the object, you take each of those have a work done associated with them. You just take all of those works. Some will be positive, some will be negative, some will be zero maybe. You add them up to get the total work done, and that is equal to the change in kinetic energy. But remember that the change in kinetic energy is just the final kinetic energy. That's 1/2 mv final squared minus the initial kinetic energy, 1/2 mv initial squared. So let's look at this in detail. If the work done is positive, that means that this term is positive. If this is positive, that means the final speed is bigger than the initial speed, and it speeds up. If the work done is negative, that means this term is bigger. That means the initial velocity is bigger than the final velocity, and it has slowed down. And if these two are the same, this will be zero, and the work done will be zero. So that is the connection between the work done and the kinetic energy. So back a long time ago when we wanted to say positive acceleration speeds things up, negative acceleration slows things down, but then we realized that it depends on which way the velocity was pointing to. We could not say that because that was not true. This we really can say. Positive work speeds things up, negative work slows things down. Zero work does not change the speed of things.